So how do I translate degrees into radians? Well, let's think about it. First, oftentimes, oftentimes, when you're confronted with a problem for the first time, you think, how can I even think about solving this? And this is a really good thing. If you've got a complicated problem, take it to something really simple. What do I mean in terms of this? It should be pretty straightforward to see. Once I said that there's 2 pi radians in a circle, half of 2 pi is just pi. So how would you convert 180 degrees to radians? And here's the trick. This is why I picked 180 degrees. You already know the answer. This is, in fact, pi radians. So let's see the formula that will get us there. Well, this is the conversion factor. I got radians on top, degrees on the bottoms. The units will cancel just like numbers in multiplication. So if I have pi radians divided by 180 degrees times, I wanted to convert 180 degrees to radians, times 180 degrees. So this is going to be my conversion. The 180 degrees convert, or they just cancel out, and degrees cancel out with degrees. And this is something that some of you might not be used to. Truthfully, a lot of times mathematicians, when they teach math, especially algebra, they don't do this degree canceling. We'll talk more about it. You'll get more comfortable with it. But so this is pi radians. And now we're going to do a couple of these because you really want to be quite good with these. Incidentally, why did I call this a unitless measure? And think about what this is again. So this radian measure, oopsie, the world's ugliest circle. This is the radius divided by the arc length. Well, what is the radius? Okay, so here's S. Suppose that this is in inches. Okay, so this is 1 inch, and it obviously isn't. So we're going to say that then this is also in inches because this is just measured the same way we measure this by whatever means we have available. So this is 1 inch, and this is IN, is for inch. Probably everybody knows that, but anybody who's done any construction does. So this angle, theta, or 1 radian, is going to be S divided by R. Theta equals S divided by R. Let me make sure that's absolutely right. Yes. As I said, I'm still tired. That means that this is going to be 1 inch divided by 1 inch. The inches cancel out. This is just 1. This is a number, and this is called a scalar. And a scalar just means it's a number. If you're going to say something is 12 inches, you have this definite notion in mind about what it is. If you just say the number 12, it doesn't really mean anything. To you, it means this notion of 12ness. $12, 12 inches, or whatever. We attach the meaning later. But right now, this is just called a scalar. And in this class, you will learn about vectors and the difference between vectors and scalars. It's pretty cool. Okay, so I was prattling on, and now we need to do some conversion stuff. So I put this up on the web page for you, which until you get your books, this is kind of what we're going to be dealing with here. And what I want to do is write down, to convert from degrees to radians, we multiply. So degrees to radians, we multiply by the factor of pi over 180 degrees. From radians to degrees, we multiply by this upside down, of course, right? 180 degrees over pi. I'm not writing the radians in right now. Maybe I will for a little while. After a while, we'll stop even writing those in, and it will just be assumed that you're comfortable with that, which we assume way too often, I already know. Example number 1. And incidentally, let me go back to something. So remember, equals R. And I remembered for a second that I might not remember this, have this memorized. This, where this is arc length, and this is the radius. In math, there are a lot of things to memorize, and for this course, this is one of these things that you're going to want to memorize. But you'll notice, I'm just teaching this course again today. I taught it last year, but I already didn't remember this. It's definitely okay to need to go look things up, and if you're even a little bit unsure, just look it up. You'll find it somewhere. It's easy to find it on the internet. Hopefully you'll find your book is helpful as well. Okay, so anyway, problem. Example 1. Turn 5 pi 6 into degrees. Well, so we have radians. We want to go to degrees. Degrees to radians. We're going to use this one. So, no, we're not. We're going to use this one because we're going radians to degrees. So this is going to be 5 pi over 6 times 180, and I'll write this D-E-G-R-E-E-S. And so this is degrees over pi radians. Okay, and now, I should have wrote this as pi radians. Okay, so already I can see a problem in making a consistent presentation. In this, they didn't even write radians behind this, and it's one of those things that you're going to have to kind of remember. So basically, they wanted you to do and be comfortable with this. 5 pi 6 times 180 degrees over pi, where this measure is already expected to be in radians. These cancel out. The 6 goes into 180, 30 times? Yeah, 3 times 6 is 18, sure. So this is 150 degrees. Also, now you'll notice I wrote in the radians here. I guess one of the things that will start to drive you crazy is the lack of consistency in using notation. As I said, for the moment, I'll try and keep writing these radians in here, but probably within the week I will stop, and it will just be assumed that when I'm talking in degrees, I'll specifically say degrees, but if I'm not, that means I'm talking in radians. When you guys get to have feedback after you watch this, tell me, feel free to let me know what I can do to make this more comprehensible. I'm sure there's something. Okay, so now as a little analysis of this, is this correct? Well, it's correct because we used the correct formula, probably, but what if I screwed something up? I do that all the time.